So here we go. So it's just, you're not going to see yourself on the screen. You're just going to see like what's shown on the screen. So I wouldn't like it's going to be what's on my main screen. So it's like, you're not going to see anything you wouldn't want to see. Like, it's not going to be you up on the screen or whatever. Cause I've even got the video thing muted right now on my end. So, but stay logged in with video on. Okay, so we're doing this one right here. Okay, so if you've already completed this one from last time, that's fine. If did we complete? I feel like we completed this one last time. Yeah. And we were about to review it. Is that correct?
7.7.
I thought we were doing the next one.
We were on the next one already?
We were on the self-test one.
11.
This one.
Yeah.
Oh yeah, perfect. You're right. We were
that's
on.
right.
Okay, you're totally right. Yeah. Okay, let's do this. Self-test 7.11a. Okay, so it gives you the answer there, right? So let's just go ahead and review this one. Let's take 3 minutes to review, and then who wants to be in charge of presenting this thing?
I can do it.
Okay, thanks, Kaiten. All right, so 3 minutes to review, and then we're gonna let Kaiten explain. And Kaiten, don't worry, I'll be your hands, so I'll write on the whiteboard.
Got you. Appreciate it.
Okay, perfect. Okay, hey Siri, set timer for 3 minutes.
I think you can annotate.
Okay, your timer is set for 3 minutes.
You can. It's easier if I do it though, because I've got a proper like little digital whiteboard here.
Okay.
Dr. J, I have to go do something. I will be right back.
Okay, Brianna, that's fine.
Graphing calculator.
Dr. J, I have a question.
Yeah, Renisha, what's up?
So for the last step, which is finding H, I was confused as to how many moles you would times by the original Q that we got in the first step.
Okay, so basically you got to figure out how many moles of phosphorus you've got. Okay.
Yes.
So you divide the mass you're given by the molar mass of phosphorus, which is what, like 31 grams?
Yes.
And
yeah.
then what you do after that is you say to yourself, okay, now I'm going to divide 216 joules by that amount to get my number of joules per mole. Okay?
Oh, you have to divide which by the moles, Dr. J?
You divide the joules by the number of moles that you have to get the total number of joules per mole of phosphorus.
Okay, got it. That makes sense. Thank you.
And then you multiply that number by 2 because you've got 2 moles of phosphorus per reaction.
Okay, it's not like you're not adding the coefficients from both elements.
Well, I mean, again, like you're dealing with this 2 phosphoruses. So it's like 0.231 grams divided by 31 grams per mole, right, equals number moles. And then you divide this number by the number of moles. And then you multiply all of that by 2 because you've got 2 moles of phosphorus reacting every time this reaction goes through.
Okay.
Okay. So I know that was kind of cryptic. I was just hustling because Kaiten's going to present the full answer right now. So, Kaiten, you ready to go?
Yep.
Okay. And Kaiten, would you rather just draw on the screen using your annotation function? That would be fine with me.
Here, actually, I've drawn it all out on a piece of paper. So could I
No, that won't work.
No. Okay.
Because we're using my screen. I'm just going to leave that. Actually, no. You want to just share your screen? I don't know how. You'd have to take a picture of it and share it. I can stop my share. That's cool with me.
Yeah.
Let me do that. Yeah, Kaiten, go ahead. So go ahead. Just hold it up or do whatever works over there. That's cool. I can reshare my screen in a second. Say hi, Lollipop. This is Lollipop. Whoop. Lollipop.
Okay, so here's how it works. So we're given the heat capacity is equal to 216 joules per degree Celsius multiplied by 11.06 degrees Celsius, which was raised by what is that, 231? I can't read my own handwriting backwards.
Oh, sorry. I actually
grams
Googled this up.
phosphorus.
Go ahead.
Right?
And you're right. Yeah. I misread
So
it.
that,
Go ahead.
yeah, so that'll give you then just about 3,400 joules per 0.231 grams of phosphorus. So you then take the molar mass of phosphorus, which is 31 grams per mole, multiply 31 grams per mole by 2,400 over 0.231. That gives you 320,000-ish joules, or 320 kilojoules. Now you go back in and plug in the chemical reaction. 1 phosphorus atom plus 3 chlorine atoms makes 1 molecule of PCl3, except that chlorine doesn't exist on its own. You have to have Cl2, so you then multiply everything by 2, which means you need to multiply the enthalpy change by 2. So you then get 2 phosphorus plus 3 Cl2 turns into 2 PCl3. I think I forgot the coefficient there, with an enthalpy change of minus 641.2 kilojoules, right? Because that's the amount of heat leaving the system, because it tells us it's an exothermic process.
Kaden, you want to like send a picture of that to like my Gmail or something?
Sure.
Thank you so much.
Okay. Actually, I'll go through it now because I should. So okay. All right. So yeah. So okay. So guys, I apologize for misreading this thing. Okay. You get this, and it's joules per gram degree C. Okay. So there's one little thing you have to do before you do those steps that I discussed, which is you have to multiply these two together. Okay. So it's 216 times 11.06, and that's going to give you yeah, I remember this last time. So 2,400 joules, right? And you got to figure out per how many moles, right? So you got 2,400 joules per this many moles. So you go with 2,400 joules times well, it's just joules per gram. I don't even. That's okay, I guess. Times. It's not gonna work. This a mole per. Okay, so you go with. I guess I wouldn't start there. You could go with. How many joules you've got, but what you really want are okay. So 2,400 joules times right per. Right. No, that is right. Per 0.231 grams, all that times 31 grams per mole. That's going to give you a big old number. Equals 340, or sorry, 320. Kilojoules per mole. And then you realize that per reaction, you've got 2 moles. So you just multiply that number by 2, and that gives you your negative 641. And the whole way this should actually be negative because that's how much heat is released. Okay, so we're talking about an amount of heat that's released. Okay.
Wait, so Dr. Dave, did you round in this instance?
Did I
Because
round?
yes.
I did, yes.
Okay, got it.
Uh-huh.
Thanks.
Yeah, I rounded. Okay, so is that clear?
Works for me.
Okay, I'm gonna erase the board in 3 seconds.
All right.
So take a screenshot if you need it, but 3, 2, 1. Okay, and this again, this lecture will be available on online. I'll put it on YouTube. Okay, so let's try 7.11b. All right, and I'm going to break us out into rooms. So we're doing 7.11b. Actually, let's work on 7.11b here. Or no, let's go ahead and go into breakout rooms. Sorry for the inconsistency. Let's go into breakout rooms, 7.11b, and I'm going to get breakout rooms started. Okay, and I'm going to break us into, we've got 14%. Let's go into 2 rooms. That's fine. So breakout rooms. Okay, so let's go to 2 breakout rooms, 7.11b. Okay, and then I'll check in with everybody. Okay. Okay.